and what adds to give us b, which is -3. So the only factors that could do that are -7, +4. So since we can use a shortcut, we can just write x minus 7 times x plus 4. We get equals 0. Take each piece, set them equal to 0, and solve. Okay, and that is our solution. So -4, 7. Now, we also sometimes have to factor by grouping. That happens when our a is greater than 1. So when we have this here, we still start with the same idea. We check for a GCF if there is one, and then we figure out what multiplies to give us a times c. A times c is 36, and we have to figure out what adds to give us b, which is -13. So in this problem, the only things that multiply to give us 36 but add to give us -13 is -9 and -4. So we will rewrite this as 3x squared minus 9x minus 4x plus 12. Take GCF out of the first two. It is 3x, leaves us with x minus 3. -4 is our GCF out of the last two, leaves us with x minus 3 equals 0. Part that's the same times what's left over. Set each piece equal to 0. X is equal to 3. And if we do 3x minus 4 equals 0, add 4 to both sides, then divide by 3, we get x is equal to 4/3. So our solution is x is equal to 4/3, 3. Now, whenever it is easier to use factoring is specifically when the equation is easily factorable. So that only happens when we have rational solutions. Okay, so if it's going to be rational solutions, so that's when your b is greater than 0 and perfect square. Now, I'm going to be honest with you. The best time to use factoring is when a is 1 and you can use, and it is factorable. If a isn't 1, it's not a time-saving choice to do factoring. So if a is 1, that's when you need to check, hey, can I factor this? And see if you can use the shortcut. So especially part that's important is this here. Now, let's go ahead and look at our next page, which is our solving by square roots. So whenever to solve by square roots, you have to isolate your x squared or your x minus h squared. So whatever is being squared, it has to get by itself. Then once you get it isolated, you're going to take the square root of both sides, isolate the x if needed, and solve both cases. That's both the positive and the negative. And if you have a negative, remember, I is equal to the square root of -1. And you will simplify any radicals when you need to using perfect squares. I listed the first 10. So for this first one here, we're going to isolate our x squared term. So in order to do that, I'm going to add 54 to both sides. We get x squared is equal to 54. We're good to take the square root of both sides. X is equal to, we got to worry about positive and negative. 54 is not a perfect square, but we can split it into the square root of 9 times the square root of 6. The square root of 9 is 3. Can't take the square root of 6, so we get positive negative 3√6 as our answer. Now we're going to look at the second equation here. So for this one, we already have our squared term isolated, so we are good to take the square root of both sides, and we get x minus 10 equals positive negative. The square root of 121 is 11, so we add 10 to both sides, and we get x is equal to 10 plus or minus 11. So here we have to do both cases. 10 plus 11 is 21. 10 minus 11 is -1. So our solutions are -1 and 21. Our last problem is x squared plus 12x. So we have to isolate our x squared term. So we're going to subtract 12 on both sides. Get x squared is equal to negative 12. Take the square root of both sides. X is equal to positive negative. Now, I can't take the square root of 12, but I can simplify. I'm going to split it into the negative part and 12. So the square root of negative 1 is I times, we can't take the square root of 12, but we can split it into the square root of 4 times the square root of 3 to get 2 root 3. So it would be positive negative 2I times the square root of 3. And that is how we solve by square roots. And so you use this when there is no bx term. Okay, so there is no bx term. Or you can think of that as having only one term in the entire question that has an x in it. So like most of these questions will either be in the form ax squared plus c equals 0, or they could even be in x minus h squared plus k equals 0. But in both of these equations, there is only one x value in either. All right, the next section is solving by completing the square. Okay, so the first thing we have here is all of our steps for completing the square. So we rewrite it by moving c. So this step here is just move c. Then we divide the equation by a. We take half of b and square it, then add it to both sides. And then we have to factor the perfect square trinomial we get from doing that. Take the square root of both sides and solve for both cases. So let's go ahead, and at the bottom it still has the same things as it did for solving with square roots. I is equal to the square root of negative 1, and it also gives us our list of perfect squares. So for completing the square, we start by moving c. So I'm going to add 10 on both sides, and we get x squared plus 6x is equal to 10. I'm going to divide everything by a. Okay, so I get x squared plus 6x equals 10. Now I'm going to take my b term, and I'm going to do 6 divided by 2 squared. 6 divided by 2 is 3. 3 squared is 9. So I'm going to add 9 to both sides here. Now, this is a perfect square trinomial, so we're going to factor that. What multiplies to give us 9 adds to give us 6 is 3 and 3. So we get x plus 3 squared equals 19. Now we're going to take the square root of both sides. X plus 3 equals positive negative. Can do nothing with that, so positive negative root 19. Subtract 3 on both sides. X is equal to negative 3 plus or minus the square root of 19 as our solution. All right, now for this one here, same thing. We're going to start by moving c, so we're going to subtract 14 on both sides. We get 2x squared minus 16x is equal to negative 14. Divide everything by a. We get x squared minus 8x is equal to negative 7. Now we're going to take our b term, which is negative 8, divide that by 2 and square it, which we get negative 4 squared, which is 16. Add 16 to both sides. We get x minus 4 squared is equal to 9. Now we're going to take the square root of both sides. We get x minus 4 is equal to positive negative 3. Add 4 to both sides. X is equal to 4 plus or minus 3. Do both cases. 4 plus 3 is 7. 4 minus 3 is 1. So our solutions are x is equal to 1, 7. Now, completing the square always works. But the time when it is actually efficient to use is when A is 1 and B is even. Okay, then our last section is solving by completing the square, or solving by square roots, and I'm going to do that in a separate video.